Today we will discuss about electronic configuration. Now, we have already discussed that electrons are found in the orbits which revolve around the nucleus. Now, we do not find electrons haphazardly in any number in any orbit. They follow a certain pattern or a certain rule. So, this arrangement of electrons in the orbits is known as electronic configuration. Now we will do the rules of arranging electrons in the orbits. So first we have the nucleus, and surrounding the nucleus is the first orbit. The first orbit can accommodate only a maximum of 2 electrons. So it can be less than 2 but not more than 2. Then from the second orbit onwards, the maximum number of electrons an orbit can hold or accommodate is 8. So first orbit, maximum of 2 electrons, and then from the second orbit onwards, maximum of 8 electrons. Now the other rule. Without filling the first orbit, you cannot jump off to the next orbit, that is the second orbit. Without filling the second orbit, you cannot jump off to the third orbit and so on. That means first you have to fill the first orbit with a maximum of 2 electrons, then you can go to the second orbit. You have to fill the second orbit with a maximum of 8 electrons, then only you can go to the third orbit. You cannot fill in the first orbit with one electron and then go to the second orbit, fill it with just 2 and 3 electrons and jump off to the third orbit. You have to fill in the first orbit with a maximum of 2 electrons, go to the next orbit, fill it with a maximum of 8 electrons if available, then go to the third orbit. So I will explain this with the help of some examples. Now, see the first example. Suppose an atom has 12 electrons. So how will we arrange electrons, or what will be the electronic configuration? So the first orbit, as I told you, can hold a maximum of 2 electrons. So out of those 12 electrons, I will put 2 in the first orbit. So out of 12, if I put 2 in the first orbit, how many left? 10. I go to the second orbit. Second orbit can hold a maximum of 8 electrons, not more than that. So out of the remaining 10 electrons, I fill the second orbit with 8 electrons. So now how many left? 2 electrons. So I go to the third orbit and then fill the third orbit with 2 electrons. So without filling the first orbit with 2 electrons, I cannot go to the second orbit. Without filling the second orbit with a maximum of 8 electrons, I cannot go to the third orbit. So what will be the electronic configuration? 2, 8, 2. Now let's see the second example. Suppose an atom has 7 electrons. So as I've already told you, first orbit will have a maximum of 2 electrons, and without filling the first orbit, I cannot go to the second orbit. So if I put 2 electrons in the first orbit, how many electrons left? 7 minus 2, 5. So the second orbit will have 5 electrons, and my electronic configuration will be 2, 5. I hope you all understood this example. It had only 7 electrons, out of which 2 were placed in the first orbit. So how many left? Only 5 electrons are left. And as I told you, from the second orbit onwards, you can place a maximum of 8 electrons. So in the second orbit, you will fill in 5 electrons. So that means this atom has only 2 orbits. Now let's see the next example. Suppose an atom has 20 electrons. So obviously first orbit 2 electrons. How many left? 20 minus 2, 18. So in the second orbit maximum how many? 8 electrons. So the next 8 electrons will go in the second orbit. So how many left now? 2 plus 8, 10. So 10 more electrons are left. Now we'll go to the third orbit. Third orbit also can hold a maximum of 8 electrons. So in the third orbit, out of the remaining 10, I will put the 8 electrons. How many left now? Only 2 electrons. So now we have another orbit, that is the fourth orbit, which will hold the remaining 2 electrons. So in this case, the electronic configuration is 2, 8, 8, 2. That means it has 4 orbits. So if you see, the more the number of electrons, more the number of orbits. We learned how to calculate the electronic configuration. Now we will learn how to draw this electronic configuration. We call it the orbital structure diagram. So once we calculate the electronic configuration, we have to draw the orbital structure diagram. So listen carefully how you are going to draw it. To learn how to draw the orbital structure diagram, let's go back to example number 1. We have already calculated the electronic configuration of an atom which has 12 electrons, that is 2, 8, 2. That means how many orbits does it have? 3. So let's start drawing. So in the center, we have to draw the nucleus. And we already know inside the nucleus we have protons and neutrons. Now you have to calculate the number of protons and neutrons from the given atomic number and mass number. Then we draw the first orbit around the nucleus. Then we draw the second orbit and then the third orbit. Now we know first orbit has how many electrons? 2. So make 2 electrons in the first orbit. Second orbit has how many electrons? 8. So draw 8 electrons in the second orbit. And the last orbit has how many electrons? 2 electrons. So just draw 2 electrons in the third orbit. And this is called the orbital structure diagram. Now let's see the second example. The second example was an atom with 7 electrons. The electronic configuration we calculated was 2, 5. That means this atom has only 2 orbits. So first draw the nucleus with the number of protons and number of neutrons. Then draw the first orbit and then the second orbit. First orbit has how many electrons? 2. Second orbit has how many electrons? 5. So draw 2 electrons in the first orbit and 5 electrons in the second orbit. So this is the orbital structure diagram of your second example. Now come to the third example, an atom with 20 electrons. We have already calculated the electronic configuration 2, 8, 8, 2. How many orbits does it have? 4. So now let's draw the orbital structure diagram. So first draw the nucleus, write the number of protons and number of neutrons, draw 4 orbits, and then draw the number of electrons in each orbit. So first has 2, second has 8, third also has 8, and the last one has 2 electrons. So this is the orbital structure diagram for the third example. Now let's do some examples together. See example number 1. Oxygen with superscript 16 and subscript 18. Now in the previous class we have already discussed about this. So let's revise. We use the formula XAZ where A stands for the mass number and Z stands for the atomic number. So in this case, mass number, that is A, is 16 and atomic number, that is Z, is 8. We have also discussed that atomic number is equal to the number of protons and the number of protons is always equal to the number of electrons. So if the atomic number is 8, number of protons will also be 8, number of electrons will also be 8. Let's calculate the number of neutrons. Number of neutrons is A minus Z, that is 16 minus 8, that is equal to 8. Now we will calculate the electronic configuration as I have taught you. So how many electrons are there? 8. So first orbit will have 2 electrons. How many left? 6. So the 6 electrons will be placed in the second orbit because the second orbit can hold a maximum of 8 electrons. So 6 electrons will be placed in the second orbit. So what is the electronic configuration? 2, 6. Now we will draw the orbital structure diagram as I have taught you. So first the nucleus. So how many protons did we calculate? 8. Neutrons also 8. So within the nucleus write P8, N8. So how many orbits are there? 2. First orbit has 2 electrons and the second orbit has 6 electrons. So this is the answer for the first example. Let's do the next example. Sodium Na2311. So like the previous example, write the formula XAZ. A stands for the mass number, Z stands for the atomic number, mass number 23, atomic number 11. We already know that atomic number is equal to the number of protons, which is equal to the number of electrons. So if atomic number is 11, number of protons is also 11, number of electrons is also 11. Let's calculate the number of neutrons. A minus Z, that is 23 minus 11, which is equal to 12. Now let's calculate the electronic configuration. We already know the number of electrons is 11. As I have taught you, first orbit will hold a maximum of 2 electrons. So 2 electrons in the first orbit. How many left? 11 minus 2. Now 9 electrons are left. In the second orbit, we can put in or add only 8 electrons. So out of the 9 electrons, 8 electrons we will put in the second orbit. How many left? 1. So in the third orbit, we will place 1 electron. So the electronic configuration is 2, 8, 1. Now let's draw the orbital structure diagram. First the nucleus, then within the nucleus protons and neutrons, which we have already calculated, P11 and 12. Then we know the atom, that is sodium, has 3 orbits, so draw the 3 orbits. First orbit has 2 electrons, second orbit has 8 electrons, and the third orbit has 1 electron. So this is the answer for the second example. Now let's do one more example. Calcium 40, 20. So we have already discussed that we have to use the formula XAZ, where A stands for the mass number and Z stands for the atomic number. So the mass number for calcium is 40, atomic number is 20. We know that atomic number equals to number of protons, which is equal to the number of electrons. So if atomic number is 20, number of protons is also 20, number of electrons is also 20. Now calculate the number of neutrons, A minus Z, that is 40 minus 20, which is equal to 20. Now come to the electronic configuration. We have already calculated the number of electrons is 20. So first orbit will have a maximum of 2 electrons. So first orbit will have 2. How many left? 20 minus 2, 18. So second orbit will have 8. How many left? 18 minus 8, 10. So third orbit will have 8 electrons. And the last orbit, that is the fourth orbit, will have 2 electrons. So please remember, without filling the first orbit, you cannot go to the second orbit. Without filling the second orbit, you cannot go to the third orbit. Without filling the third orbit, you cannot go to the fourth orbit. First orbit can hold a maximum of 2, and from second orbit onwards it is 8. Now let's draw the orbital structure diagram. So in the center, the nucleus with protons and neutrons. We have already calculated the number of protons and neutrons. Number of protons 20, number of neutrons also 20. We have also calculated the electronic configuration, that is 2, 8, 8, 2. That means a calcium atom has 4 orbits. So draw the 4 orbits. First orbit has 2 electrons, second orbit has 8 electrons, third orbit has 8 electrons, and the fourth orbit has 2 electrons. So this is the answer for this example. I hope you all did all the examples along with me and have understood how to calculate the atomic number, mass number, number of protons, number of neutrons, number of electrons, the electronic configuration, and how to draw the orbital structure diagram. Thank you. Bye bye.